chemistry students, let's get ready for our mass and volume lab, where we're going to practice some measurement and use the measurements and data that we collect to actually answer a question. The question that we're going to try to answer in this lab is, how can I use the slope of a line on my graph to determine the density of an object? So a quick review about what density is. Density is what we call a derived unit. I don't measure density directly. I don't have a device that will give me the density of an object. I have to first measure the mass in grams on our electronic balance. We're going to measure the volume using water displacement in a graduated cylinder, and then I divide the mass by the volume. And my units then carry over. Neither of those units cancel. Density is also a set physical property that can be used to identify substances, because all pure substances have a known set density value. So if I had an unknown metal and I determined its mass volume relationship, I could look up in a reference guide and identify that metal potentially based on its density. We also want to take a minute to review the idea of slope. From a simple standpoint, slope is simply the steepness of the line. The slope could be positive or negative. In math class, we often define that as rise over run and use the equation change in y over change in x. In other words, m, or slope, is equal to the difference in value between two y coordinates on my graph divided by the difference in the value of two x points or coordinates. So you can see the quick rundown of how I use that slope equation by selecting 2 points on both my y and my x axes and recording their coordinates and just plugging those coordinates into my slope equation. Remember that in science class, we never leave our slope as a ratio. We always divide it out so that we have a whole number, and we include units on those numbers. The same unit that is on my y-axis and my x-axis are going to be incorporated into my slope value. So on the first day of the lab, each lab group will obtain a sample of marbles, some small rubber stoppers, and some nails. Each group may have a different number of items, so if you don't have the same number of marbles as the team next to you, that's okay. Ultimately, we're going to report out class data, so if there are 12 lab groups working in your lab, we should have 12 data points for each of those 3 samples on our graph. Remember to use a little weigh boat from your lab drawer. Place it on the electronic balance. There will be a 0 or tar button that will subtract the weight of that weigh basket. Then you can add all of the samples. So if I have 5 marbles, I'm going to get the mass of all 5 marbles, recording it to the correct number of sig figs. For the volume of our samples, we're going to use the water displacement method, in which I'm going to add a volume to my graduated cylinder and record that initial volume. It doesn't have to be on an exact volume line. Simply add about half fill the graduate, record that initial volume, carefully add your sample to the water. In this case, my solid that I want to determine the volume of is a little piece of green jade. Notice that the volume was displaced by adding that, or the volume went up to 60.5 milliliters. And so the volume of my green jade object is the difference between my ending and starting volume, or 10.5 milliliters. Also remember that you're going to want to read your volume at the meniscus. So I'm reading the low part where that water curves down in the graduate at eye level. And for most of us, reading our graduates from the lab bench at eye level means we're going to have to scoot down a little bit so that we're not looking at it from coming from above or coming from below. I'm going to get the most accurate reading from reading it at eye level. The second day of the lab is where we're going to take all of that class data and construct a graph of it, determine the slope of the line, which in turn will help us determine the density. So we'll be using Excel, which you may need to release from self-service. And these are all of the directions that I'm going to walk through in just a second and demonstrate on the actual Excel program for you. So you're going to first select one set of data and insert a scatter plot. because we want mass over volume, which is change in Y over change in X, and Excel is always going to take my first column of data and automatically put it on the X axis. We just want to make sure that our first column is the volume data. After I get that scatter plot on my Excel sheet, I'm going to insert a trend line. That trend line is a best fit line that's going to go through the center of all my data points. And here's where you can find that trend line. I'm then going to insert the data for the other two objects, the stoppers and the nails. I am going to label the axes with a unit and add a title. I'm going to add my my minor horizontal and vertical grid lines. And again, that's going to help me delineate the coordinates of my X and Y values a little more carefully. I'm going to show all of the work for how I perform the slope calculation as we just reviewed. I'm going to show all of this work in my lab notebook for the coordinates that I read off my graph. I do not want to use just two coordinates from my lab data. The whole point of doing compiling the group data, the class data, and plotting all of those points with a trend line is that I'm getting that best fit line that's going to most accurately represent the average relationship between mass and volume. So I'll show all of that work and calculate the density for all three objects, and then we'll turn our graph in on Canvas. So let's take a look at some sample data that I have for this lab. The first thing we want to do per those instructions is insert a scatter plot. So I've selected just that first set of data, go to Insert, Scatter Plot, and I just want to check and make sure that it looks like my mass data is on the y-axis, mass over volume, change in y over change in x, and indeed that appears to be the case. So I can go ahead and add my next set of data, and to do that I'm going to go over here to Chart Design, stay clicked on your graph. I'm going to select data. I'm going to add another data set, and the name of this data set is going to be nails. I can select that from my data table, but it might be helpful for me to actually name that nails rather than just leaving it as my spreadsheet values. My X value, remember, is going to be the volume. So I'm going to select that and pull all of that volume data down. So it's telling me that it is C3 through C13, C3 through C13. That looks accurate. And I want my Y values to be my mass data. So I'm going to highlight and insert those. Okay. And now those points are plotted on my line. Next, I'm going to select data, add my third data set. We're going to name this stoppers. We are going to select our X or volume values. We are going to select our Y or mass values. And it will plot those data on my graph, those data points on my graph as well. Now that I have all three of those data sets on my graph, I can insert a trend line. So as the instructions indicated, I'm going to go over to Add Chart Element, Trend Line. I want a linear trend line. Unfortunately, it's only going to let me select one of these at a time. So I'm going to have to go back through and first add my marble trend line. Go back to Trend Line, Linear, add my nails trend line, go back to trend line, linear, and add my stoppers trend line. The one thing that I failed to mention in the instructions is we definitely want to insert a key on here, and I can do that here as well. I want a legend. I'll just put it over here to the right on my graph, make this a little bit bigger. We don't really need to see that data anymore. And now the 3 lines on my graph are color coded. Looks to me like some of the data was a little tighter than others. We definitely have some outlier points here. For the marbles, which are blue, it looked like they were, most of that data is clustered very closely to that trend line. But you can see the value of a trend line, because if this were my individual data point, my calculation for the change in Y over change in X for that value might not be very accurate. A couple other things we want to do is add those grid lines. We want to add minor grid lines to both the vertical and horizontal axis so that it makes it a little bit easier. I've just added more lines on the graph, so it's going to be easier for me to read 2 points on the line. I can add a chart element and label my axes, and I can also put a chart title on the graph. So remember that when you go to calculate the slope now, that you are not using your individual slope value or your individual mass and volume values. I want to read any 2 points off of each of the lines. And I typically want 1 point that's kind of down on the low part of the line and one that's on the upper part of the line. Remember, based on this equation that we looked at, you need to make sure that you are showing all of the work. We need to see in your lab report the 2 Y values that you used and the 2 X values that you used, and then divide those out and put a slope value with correct units. Good luck. See you in the lab.